All right, welcome back. Hononegah, Algebra 1, Section 5.3. We're going to learn our last way of solving systems of linear equations. We already learned solve by graphing, and then we learned solve by substitution. So this is what's called solving by elimination, and this is my favorite. So maybe as we go through this, you can tell that it's my favorite, but here we go. If you add two equations together, the equation that you get is also true. Here's what that means. 3 plus 4 equals 7. Everybody would agree with that. And 2 plus 3 equals 5. But if I added the columns here, 5 plus 7 equals 12, and that's also true. So what that means is if you have two equations that are true and you add them together, the resulting equation is also true. So in this one, 3 plus 3 is 0, plus 8 would equal 8. And this is very important. These are referred to as opposites. And so what's going to happen is anytime you have opposites, you'll always get 0. Like 3 and negative 3 will be 0. And negative 1 and positive 1 would be 0. Negative 3x and positive 3x would be 0. So notice those are opposites that have variables. And negative x and positive x would also be 0. So again, anytime you have opposites, and the goal with elimination is to have opposites. So here's what it looks like. Solve the system of linear equation using elimination. Because the 2x and the negative 2x are opposites of each other, I can eliminate the x and merely add the y and the constant. And then I can solve what's left because I'm down to only having one letter. So 5y equals 5. I divide by 5, y would equal 1. Now, I am not done yet. That is merely the y of the answer. I still need to find the x answer. So I'm going to go back up into one of the original questions up here. I know I already crossed them off, but I'm going to go back up to the original question, and I'm going to now put 1 in for y. So I took the top equation and put 1 in for y. So 2x plus 3 equals 7, and this goes back to chapter 1. I can solve an algebra question and get x to equal 2. Always write your answer as an xy point. So this is the point 2, 1. So I'm looking at the next one. Notice the y's can be canceled. 1x and 1x make 2x. And now I have one letter that I can solve for. So x is 8. Go back up into either one of the original questions. So I can go in the top or the bottom. I'm going to go in the bottom. So 8 plus y is equal to 12. Subtract 8, y would equal 4. So again, writing your answer as a point, an xy point, we have x is 8 and y is 4, so that is the point 8, 4. You try the next one. Go ahead and hit pause and see if you can do this one by yourself. All right, welcome back. So now the y's can be eliminated because they are opposites, and I can solve for x to be 2. Then take either one of the top two equations and put 2 in for x. And so now you'll end up getting an algebra question from like chapter 1 that you would be able to solve. So subtract 4 from both sides, divide both sides by 5, and so putting it as a point, this would be the point 2, 1. So hopefully you got that right when you did it on your own. Now, not everything is always going to be opposites to start with. For instance, 5x and 2x are not opposites. Negative 4y and positive 8y are not opposites. So therefore, sometimes you'll have to multiply first. Here's what that means. I need to create an opposite. How I create an opposite is I multiply an equation by a number. So if I multiply the top equation, let's say by 2, 10x minus 8y is equal to 6. So all I did was take the top equation and multiply by 2. Then I'm going to leave the bottom equation alone. That created an opposite. So multiplying everything through by a number, okay, creating an opposite on its own. So the y's would cancel or be eliminated. Now this one ends up being a fraction. I get 1/3. So sometimes you're going to get a fractional answer. So this isn't a very good example for us to probably start off with, but I'm going to keep going. So I'm going to put 1/3 in for x. So 2 times 1/3 plus 8y was equal to -2. So that's 2/3. So now I'm going to subtract 2/3. So I'm going to subtract 2/3 from both sides. And again, those of you that might have some struggles with fractions, this probably isn't going to help you much, which is -8/3. Then I'm going to divide by 8. And so that ends up being -1/3. So the actual answer here is 1/3 for x and -1/3 for y. So a horrible example here. I'm going to go ahead and move on relatively quickly here and hope that the next one isn't necessarily quite that rough. I want to create opposites. So what if I multiplied this bottom one times 4? So I have -8x, +4y, and -12. So I multiplied the bottom one times 4. So this one times 4. And then I left the top one alone. The y's would cancel, leaving me with -5x adding and -5. So this one is a much better example. X is equal to 1. Now I'm going to go back up into the original question, and in one of the two problems, I'm going to put 1 in for x. So I'm going to do the top one. 3 times 1 minus 4y is equal to 7. So I'm going to subtract 3 and divide by -4. So y would equal -1. So writing this as a point, we're talking about 1 for x and -1 for y. And again, that is a much better example and something that we actually probably are going to put on a test or a quiz, something similar to that in which they're integer points, not necessarily fractional points. So a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B gets 2 large vans and 3 small vans. So here's what we're going to do: X and Y. X is going to be the large vans, and Y will be the small vans. So let's read this sentence again. It says 5 large, 2 small for $235,000. Location B gets 2 large, 3 small, for a total of $160,000. This is creating what's called a system of equations. We're going to do a lot of these over the course of the rest of this chapter, in which we'll have word problems that you'll have to create a system. So now, using elimination, I want to create opposites. So I want to create a situation in which either the x or the y is eliminated. So how could I do that? Well, I want to, let's say I multiply the top one by 3. So off in the bottom here, I'm going to multiply that one by 3. So 15x, 6y, and 235,000 times 3. Sorry, I'm going to pull out a calculator here. So 235,000 times 3 is 705, so $705,000. Next, I'm going to multiply this equation by -2. So now we're talking about -4x, -6y, and -320,000. By multiplying the top by 3 and the bottom by -2, I have created a situation in which the y's can be eliminated. So now, just adding what's left. So now, I get 385,000. Divide by 11. I get 35,000. So every single van costs $35,000. So the large vans cost $35,000. Now, how am I going to find out how much the small vans? I'm going to go back up here and I'm going to put 35,000 in place of one of the original questions. So let's say I use the bottom one. 2 times 35,000 plus 3y equals 160,000. So I get 70,000 plus 3y equals 160,000. Subtract 70,000 and get 90,000 and divide by 3. So the big vans cost 35,000 and the small vans cost 30,000. Next, now notice that in order to do elimination, everything has to be lined up. And so you'll notice the top one has 3x plus 2y equals 8, and the bottom has 2y equals 12 minus 5x. Everything's not lined up. So I'm going to take the bottom equation and I'm going to move it around. So I'm going to add 5x to both sides. Now everything's lined up. Notice the top equation and the bottom equation, or the new bottom equation, have an x, a y, a equal signs, and a number. What if I multiply this top equation times -1? Well, I'd have negative 3x, negative 2y, and negative 8. The y's would cancel. And I end up getting x to equal 2. Remember, you are not done. You have to go back up into one of the original questions and put 2 in for x. I'm going to do the bottom one. 2y equals 12 minus 5 times 2. Remember, I'm putting 2 in for x. So 2y would equal 12 minus 10. Divide by 2, y would equal 1. So the answer to this question, again, writing it as an ordered pair, is the point 2, 1. 2 for x and 1 for y. Again, this situation, the y's, the x's, the equal signs, nothing's lined up. So I'm going to add 6y to both sides to get the top to be 3x plus 6y equals 12. And I'm going to leave the bottom one alone for right now. I don't have opposites. So the x's and the y's, the equal signs are lined up, but nothing actually cancels out. So I'm going to take the bottom equation here, and I'm going to multiply it times -2. So positive 2x, negative 6y, negative 12. 3x plus 6y equals 12. Now, this is a very common mistake. Put a star by it. People are not going to necessarily like this question. They're going to cancel, and I'm going to get 0. And it is okay to have 0 as an answer. There's nothing wrong with having 0 as one of your possibilities. So now I'm going to put 0 back into one of the original questions. And I'm going to use the bottom one. So -0 plus 3y equals 6. Well, -0 is just 0. So divide by 3, y would equal 2. So these two cross at the point, or intersect at the point 0, 2. Hit pause for a second, and you try. All right, welcome back. Let's see if you guys got it right. It doesn't matter if you want to get rid of x or get rid of y. In this case, I'm going to try to get rid of y. So I'm going to multiply the top one by 2. So if I multiply the top one by 2, I get 8x plus 6y equals 16. Common mistake, by the way, is to not multiply everything in the top equation by 2. Now I'm going to multiply the bottom one by 3. By doing that, I have created a situation in which the y's will cancel out. Add what's left. So divide by 11, x would equal 5. Again, you're not done. That's just the answer for x. So now if I put 5 back in for x and then do some Algebra 1 skills from Chapter 1, I get y to be -4. So these two, writing this as an ordered pair, is 5, -4. Do not forget to write it as an ordered pair. Ultimately, if you forget, it probably will take off a half point. So ultimately, don't let that happen when you know what you're doing. So this is just a summary of what we've learned. So again, anytime we're going to solve a systems, you're going to, by elimination, you want to arrange them if you need to, so that everything lines up. You want to create to get opposites if you need to. Then you're going to add the two equations together to get rid of a variable, and then you're going to solve and go back and write your answer as an ordered pair. These are the 3 ways that we've learned. We've learned graphing, we've learned substitution, and today we learned elimination. So those are the 3 methods. This is the only 3 methods we're going to learn and how to solve a system of equations. So now this 5-3 day 1, there's a worksheet. So please make sure you look for the 5-3 day 1 worksheet. If you have any questions, please make sure you reach out to your teacher, and good luck.